We are going to talk about the general gas equation, or sometimes it is called ideal gas equation. And in this video, the outline of the video is how to derive this general gas equation and its example. Okay, so let's start with the derivation of general gas equation. First of all, in previous videos, we have discussed the Boyle's law and Charles' law. And the statement of Boyle's law and Charles' law, let's rewrite the statement. So, the statement of Boyle's law, first of all, the volume of given gas is inversely proportional to pressure. This is the statement of Boyle's law. And for more information about Boyle's law, there is a video. The link is given in the description. And the statement of Charles' law, again, the statement of Charles' law is also uploaded on the channel. Kindly visit it if you need more information about it. So these are two laws of gases that we have already previously discussed. The volume of given gas is inversely proportional to pressure, and the volume of given gas is directly proportional to temperature. There is another law that is called Avogadro's law, and it is stated as the volume of gas is directly proportional to number of moles. Number of moles is directly proportional to volume, and this is the statement of Avogadro's law. So if we combine these three, we have volume is directly proportional or inversely proportional to nT over P. So by mathematical proportionality, if we remove this proportional sign, we have a constant. Let's say V R nT over P. Now, or in some cases or in some literature, this is found as PV equals to nRT. Now this is known as the general gas equation or ideal gas equation, and here R is general gas constant. Okay, so let's make a before and after situation. For example, we have the same gas for 1 mole. First of all, for n equals to 1 mole, if we are taking the 1 mole of gas, so we have before and after situation. For example, the V1 and P1 equals to RT1 at gas temperature 1. This is a before situation. And after situation, we have the change in pressure, volume, but this constant will be same, and change in temperature. So this is after situation. And by mathematical equality, we can write it like this one: P1 V1 over T1 is equals to P2 V2 over T2. And this formula we can use for before and after situation. This formula actually we can use before and after situation. Okay, so here are the values of R. This R is general gas constant in joules. So for in joules we have pressure is this, and this is the unit of Newton into meter square, means the pressure equals to force upon area. This is the unit of pressure, and this one is equals to 1 atmosphere equals to this thing. So there are too many units of pressure. Some in times we have Pascal, atmosphere, torr, and this one Newton over meter square. The volume of 1 dm cube equals to 10 power minus 3 meter cube, and this one is equals to 0.0224 meter cube. This volume actually is derived from the Avogadro's law. And for n equals to 1 mole at T standard temperature 273 Kelvin, we have the value of R. By putting this all, we have this is the value of R, and the unit of R is joule per Kelvin mole. Similarly, we have the value of R in dm cube per atmosphere. This is the second or another unit of R. Here P is 1 atmosphere, volume is 22.4 dm cube, n equals to 1 mole, and temperature. These all are standard conditions. Then by putting these all values substituting, we have the value of R is this one. So it depends what is the problem, and according to data we choose the value of R. So here is one example. Given there the 40 dm cube of hydrogen gas was collected over water at 831 torr mercury pressure. This is another unit of pressure at 23 degrees centigrade. What would be the volume of gas at standard condition? The vapor pressure of water at 23 centigrade is 21 torr mercury. So first of all we need to write the data. This is a given volume is 40 dm cube. Okay, and it is given the temperature T1 is 23 plus 273 Kelvin, and this will be 296 Kelvin. Okay, now pressure, it is given that 831 pressure, but also the pressure of water should be subtracted because we need to only have the pressure of hydrogen gas, not water. So we cancel out this water pressure here, and this will be 810 torr mercury. Now the second, it is given that what would be the volume of gas at standard condition. The standard conditions are means P2, pressure 2 is 760 torr at standard conditions, and temperature at standard condition. Now we need to find the volume V2. So by before and after condition uh, we can write the relation P1 V1 over T1 is equals to P2 V2 over T2. Now make the relationship for V2. This one will be P1 V1 T2 divided by T1 P2. By putting all the values here, the value of P1 is 810, the value of V1 is 40, and the value of T2 is 273 divided by the value of T1. The value of T1 is 296 Kelvin times P2. The value of P2 is 760. By using our calculator, we have the value that is 39.32 dm cube. And this is the simplest calculations of the general gas equation. If you like the video, then thank you, and subscribe my channel and share it with your friends.